Today's video is lesson 4.4 covering multiplying polynomials with the area model. Our goal today will be to multiply polynomials using the area model, or you may have heard this model referred to as the box method. So we've learned how to add and subtract polynomials. Now we're going to learn how to multiply them. We've got a great system for doing that. So just pretty much one key term today, and it's the area of a rectangle or a square. The area of a rectangle is the width times the length times the width, or the width times the length, either way. So if you had some rectangle like this and you wanted to know what the amount of the inside of it was, what you would have to do is you'd have to take the length, you'd have to multiply it by the width to figure that out. We're going to use this system to multiply our polynomials. So let's just say, for example, we had something like 5 is the length, and let's say the width is 2. So what we do is we create a rectangle to find the area. We say, okay, the 5 is the length, and the width is 2. So what's the area? We would multiply 5 by 2, and we would get 10, right? Well, let's say, for example, that the length was not 5. Let's say it was 3 plus 2. And let's say, for example, the width was 1 plus 1. How would we set something like this up? Well, we know that the length is 3 plus 2, and we know that the width is 1 plus 1. So what we do to find the area is we would break it up into 4 smaller squares, and we would multiply each square. So 3 times 1 would be 3, 2 times 1 would be 2, 3 times 1 would be 3, 1 times 2 would be 2. So we found the area of the smaller boxes. Now the area of the entire figure will be what we get when we add them all together. So we've got 3 plus 3 plus 2 plus 2. Well, that's 6. That's 4. And 6 plus 4 is 10. So this is a numeric example, but this is exactly what we're going to do today with our examples. So here we have the first example, and it's asking us to find the rectangle that has a length of negative 5p squared and a width of 3p minus 7. The first step is going to be to identify the number of terms in the length and then how many terms are in the width. So if you look up here in the length, you're going to count up how many things you see being added or subtracted. Well, we only have one thing, so we only have one term. So here we have one term. And here in the width, we've got two things, 3p and negative 7. These are two terms, so total we've got two terms. So we've got a 1 by 2. So the second step is to set up your box based on your number of terms. So we've got a 1 by 2, so we're going to put negative 5p squared here. And we've got a 2, so we've got 3p, and we've got a negative 7. So these make up the width. So now I can go ahead and draw a line right here, since we've got this width broken up into two parts. And what we're going to do now is we're going to multiply each box. So we're going to multiply the top box, then we're going to multiply the bottom box to find the area of the smaller boxes, and then our fourth step will be to add them together so that we have the area of the entire thing. So I multiply pretty much just the coefficients, and then when I have exponents that are from the like bases, I just add them up. So 3 times negative 5 is negative 15. And p times p squared, well, total there's 3 p's being multiplied. I just have to add the exponents. Go ahead and multiply the coefficients here. We get a positive 35. And there's no p being multiplied here, and there's 2 up here, so we just say p squared. Now we're going to do our final step, which is to figure out the area of the entire thing by adding our like terms and writing in standard form. Well, neither of these are like terms, but we can write it in standard form by making sure that negative 15p to the third goes first. And this would be the area of our rectangle. Example number 2. So I'm going to count up the number of terms that each one has. This top one has 2 terms. There's 2 things being added. And the width has 2 terms. So we've got a 2 by 2. So when you create your box, you're going to break it up into a 2 by 2. So we got 2 things on the width, 2 things on the length. 2 by 2 will be 4. So we've got our 4x plus 1. And we can just write the plus 1 as a positive 1. and we've got it x minus 8. So we've got our x, and we can write the minus 8 as a negative 8. Go ahead and leave the sign with the number. Now we're going to multiply each of the little boxes. So we're going to multiply the coefficients. What's the coefficient in front of this x? Obviously we can just write a 1. That's what we know. 1 times 4 is 4. And x times x, total there's 2 x's being multiplied. We just add the exponents. Doesn't matter which order you go in from here, you just have to make sure that you're multiplying the correct terms to each other. So here we've got 1x times 1 is just 1x, which is just x. And then in this lower left box, we've got 4 times a negative 8, which is a negative 32, times x is a negative 32x. And then our last box is a negative 8 times a 1, which is a negative 8. Now, something that's really cool is sometimes, not always, but if your length and your width have the same order, meaning the degrees of the exponents are the exact same, the diagonal boxes are going to be your like terms. So you can see here we've got our like terms, x and x to the first power, and then we have nothing to combine the 4x squared with, and we have nothing to combine the constant with. So let's go ahead and write our final answer in standard form after we add. So we've got 4x squared, and we can just say plus, and in parentheses we've got our coefficient. So we've got a negative 32 plus a coefficient of 1. This x has a 1 in front of it, to the x to the first power, and then our constant, we've got nothing to combine it to. So we can go ahead and simplify this further. We've got 4x squared, and then negative 32 plus 1 is a negative 31, so minus 31, x minus 8. This would be the final answer for the area of this rectangle. Example number 3. So I'm going to go ahead and count up the terms of the length. We've got 1, 2, 3 terms. And then for the width, we've got 1, 2 terms. So for this rectangle, we've got a 3 by 2. So we can go ahead and the cool thing about expressing it like this is when I draw the rectangle for our multiplication, I should have 6 boxes because 3 times 2 is 6. So our 3 lines for the length up here, so we've got 3 parts to it, and then for the width we've got 2 parts. So total, you can see we've got 6 boxes. So that's what's kind of cool about this, to make sure that you've got the right setup. Now we can go ahead and write in our length. We've got 11x squared. We've got a negative x, which is negative 1x obviously, and 13 plus 13 is positive 13. For our width, we've got 3x squared, and we've got a negative 6x. And if you keep it in standard form when you set it up, it makes the chances of having those like terms be your diagonal boxes pretty good. So here we've got 11 times 3 for the top left box, which is 33. And then we multiply our like bases, we add our exponents, so we've got x to the 4th power. Top middle box, we've got 3 times a negative 1, which is a negative 3. And then the exponents for our like bases add up to 3. Top right box, 3 times 13. This I'm going to use the calculator for this one, so 3 times 13. $39. So we got 39, and then our exponents for the bases, we've got only 2 x's being multiplied, so we say x squared. Bottom left, negative 6 times 11 is a negative 66, and our x's, there's 3 being multiplied, 1 right here, 2 right here, for a total of 3. Bottom middle, negative x times a negative, or negative 6 times a negative 1 is a positive 6, x squared, 2 x's, add the exponents. And our last box, negative 6 times 13. Again, I'm going to use the calculator to figure this one out. Negative 6 times 13 equals a negative 78. And we've got times this x. We've got 1x being multiplied, so we leave it like this. Now we can go ahead and add up the like terms. So you can see here, there's no other x to the 4th term, and since it's the highest exponent, I'm going to go ahead and write it out first. This box is being taken care of. Now our next highest exponent is 3. We've got 1 right here, and cool, it's the diagonal box. It won't always be like this, but most of the time it will. We've got our like terms, so we can add up our coefficients here. We've got a negative 66 plus or minus 3 better, x to the third, and then our x squared terms, so we've got, our squareds happen to be the diagonal box again. So we've got 6 plus 39 x squared, and then we've got no x to the first power term to combine, so we can just write minus 78x. And we can just simplify the addition of the coefficients furthermore. So we've got 33x to the fourth. This is going to be negative 66 minus 3 is going to be negative 69 x to the third. And 6 plus 39 is a 45, so plus 45 x squared minus 78x. This would be the final answer. Two more examples. Example number 4, so I'm going to go ahead and count up the terms. So in this first, for the length, we've got 3 terms, and then for the width, we've got 3 terms. So our box is going to be a 3 by 3. Draw it fairly big. So we've got negative, or 2x squared, we got negative 7x, and we've got 18. And then here we've got 2x squared. Looked at the length again. We've got 3x squared, 5x, and a negative 2. So draw our lines so we know where to multiply, and I drew this fairly tight, so maybe kind of hard to write my answers in here, but I'll do the best I can. Okay, so now we're just going to multiply each individual box. Coefficients, 2 times 3, 6. How many x's are being multiplied? 4 x's total. Now we've got the coefficients. 3, negative 7, that's negative 21. How many x's are being multiplied? Add the exponents up, we got 3. Then we've got our far right box, 3 times 18, which is the same thing as 6 times 9, which is 54, but I want to make sure. Yep, so we got 54. How many x's are being multiplied? Just 2 x's. 10x to the third. And below that, we've got negative 4x squared. In the middle, we've got negative 35x squared. And the far right, we've got 5 times 18, which again, make sure I do this correctly, 90. And we've got just 1x being multiplied in this one. Bottom middle, we've got a positive 14. I assume that it was a negative, but it's negative times negative is positive. And we've got 1x being multiplied. And then the last box, negative 2 times 18 is a negative 36. Okay, now we can figure out what our like terms are. So we've got an x to the fourth term. I don't see any other x to the fourth term, so I'm going to write x to the fourth term, so 6x to the fourth. This box has been taken care of. And then we've got our third power. That would be our next highest power. We've got 2, we've got 10, and negative 21. So our third powers are good, and then our squareds would be the next highest exponent. So we've got our squareds, which we've got 3 of them. It's cool that the diagonal boxes lined up again. We've got negative 4, minus 35, plus 54, x squared. And then our to the first power terms, we got 14 and 90. And then our constant, we can't combine with anything, so we just write minus 36. So the last step here would just be to condense the coefficients for our like terms. So we got 6x to the fourth. This 10 minus 21 is a negative 11, x to the third. And this is going to add up to negative 4 minus 35 plus 54. Is 15. And 104x minus 36. And this is our final answer.